And that's great. And Kevin, not only that, but you helped set up the next guy here following in on you. And of course, it's Rigas Karamanos, who we've had speak with us several times before. Rigas has quite a large pedigree here. Rigas, coming from Greece and schooled in Saskatchewan and worked, as many of you know, the Wesco manager of agronomy, and then Viterra, and then you had a soil test lab in there, most recently with Cope Fertilizers. And today you're like me, you're a retired guy just looking for a bit of things to do in your spare time. So we've invited Rigas in here to address a question that came to us in our planning group is, give us an update again, kind of sort the water here on enhanced efficiency fertilizers. And so we're delighted that you're able to join us, Rigas, and we would have you kick that off here.
Well, thank you so much. It's just a pleasure and honor to be here. Appreciate it for the invitation. Very quickly, diammonium phosphate, because we're seed placing our phosphorus, diammonium DAP has been proven to be much more toxic than MAP, and that's why we never used it. That's the moral of the story. Anyway, I'm going to cover quite a bit on the role of enhanced efficiency fertilizers. So I'll start first of all by mentioning that maximum crop production cannot be, okay, it changed here, but it didn't change there. There we are. No. It changed.
Do you want me to go through more of your introduction?
There we are. Anyway, we got to remember that fertilizers and amendments are not enough. Alone cannot provide the maximum yield. You also need to know what yield crop yields are possible, and also what is the moisture that that is required. And I spent a good part of my career with the late Les Henry to develop equations about the water use efficiency of different crops, because different crops have different water use efficiency, and the prairie, Manitoba, whether you're in the Red River Valley or not, it's not an exception. So also it depends on the weather, and therefore you have to be, unfortunately we cannot predict the weather. If you knew what the weather was, it would be perfect to come up with fertilizer recommendations. And also what is really important in these days is to use products that work, to know, fertilizer products that work versus those that don't work. And it's been a very confusing time. Anyway, the enhanced efficiency products are gaining more attention because fertilizer nitrogen is gaining more attention. We've had some speakers ahead of me showing you how the economics is, how the transportation for a lot of the fertilizer. Now nitrogen is not as, but still it's not as bad as phosphorus, but still we have to take into account the fluctuating prices of the nitrogen fertilizer as well as the crops. And also, you got to realize that maximum yield does not necessarily result in maximum profit. You got to remember that in order to calculate, you have to multiply the yield increase that you get by using fertilizer times the crop price, subtract the nitrogen price times the rate, and that gives you the net. And that's when you calculate how much money you're making. So it is important to select the right fertilizer product and to use it in the right rate to achieve the maximum economic return. So I want to give you the enhanced efficiency fertilizer definition. If you go back in history, prior to April 1st, 2013, and that's not an April Fool's joke, but as of April 1st, 2013, we do not have any more regulation of efficiency for fertilizers. But prior to that, in order to register an enhanced efficiency product, it had to meet this definition, which comes from the Association of American Plant Food Control Officials. It had to have characteristics that, I have it in red, allow increased plant uptake and reduce the potential of nitrogen losses to the environment, gaseous losses, leaching, and runoff, compared to an appropriate control or reference product. And the most commonly used reference product has been urea, you know. So I know that back in, before Agrotane, you know, was international because before they sold their products, before they became Coke, you know, because Coke bought Agrotane International, they spent a lot of money to register Agrotane. I know that Nutrient Agrium, you know, they spend a lot of money to register ESN, you know, because they had to demonstrate that the product has these characteristics. And keep that in mind, that's very important. Now, very quickly, I'm not going to spend very much time on the nitrogen cycle, but when we are talking about enhanced efficiency products, we're primarily concerned about three processes that result in nitrogen losses. And that is the volatilization, the denitrification, and the third one is leaching. And when those, you know, I'm going to cover now this to show you how you can use enhanced efficiency products to reduce these losses. So why all of a sudden are we interested in enhanced efficiency products? Well, we now know that we apply the 4R nutrient stewardship principle, and it's the enhanced efficiency products are a key component to that. And it has been shown to optimize soil and nutrient management, improved crop yields, lower environmental losses, and finally grow more with less. Another thing which is very, very important has been developed the last few years in Western Canada. People are using enhanced efficiency products because of operational efficiencies versus agronomic efficiencies. And what do I mean by that? Well, I will show you right away, and maybe I should go and show it to you. This is the number of farms in Western Canada. Between 1950, there were, as you can see, 490,000 farms. Now we have 1,400, 1 million, I'm sorry, there were, my apologies, there were 78,000, say 79,000 farms in Western Canada. No, I'm being goofy. There were, my apologies. The number of farms were 400, you know, yeah, there were 78,000, no, 248,000. That's what it is. Now there are 90,000, you know. And the average size was about 500 acres. Now we're up to 1,500 acres. What does that mean? It means that now farms are larger. And I've gone and visited people that have 20,000, 30,000. One fellow north of Esterhazy in Estevan in Saskatchewan, that's 40,000 acres. Those people have to have operational efficiencies. And operational efficiencies sometimes means that they're not going to use the best management practices for nitrogen that we'll cover in a moment. So it's very important for economic development. So the first step in managing your soil, of course, is knowing what's in it. And of course, that is your soil test. Then you need to decide, once you soil test, what you're gonna fertilize for based on your recommendations. So choose a soil testing lab that gives you the right recommendations, or have a system that you develop. And then what you're going to fertilize with, which means you have to choose the right product. There are major factors that make products different or the same. The chemical makeup, the soil chemistry, plants themselves, and combination of these three components. Now, of course, when you look at that, you're assuming that you're using the right placement, because placement in itself has an impact on the fertilizer efficiency. So there are a number of enhanced efficiency products. There are uncoated, slowly available fertilizers that contain nitrogen, like urea aldehyde, formaldehyde, IBDU. Now, I finished my bachelor's in 1968, 67. No, maybe even before that. And anyway, some of these products were in existence at that time. We don't have them here. They're primarily products that belong to the low, like if you go to California and places like that, Physical coating. We had sulfur-coated urea, but once the polymer-coated urea came into the picture, all the sulfur-coated urea seemed to have disappeared from our market, And then combination of products, and then stabilized material. We have nitrification inhibitors, urease inhibitors, and dual inhibitors. And I have pointed with stars what are the common products that we use in Western Canada. So when it comes now to urease inhibitors, when to consider using a urease inhibitor? When the potential for volatilization is high. That means when, and the volatilization is a physical-chemical reaction. It has, the product has to be in contact with the atmospheric oxygen. It's mediated with an enzyme. So surface product, broadcast of urea or surface spray of UAN will presumably, conceivably, unless if there are exceptions, result in volatilization losses. Prolonged exposure of fertilizer with no rain, heavy residue, and a lot of dews. That's the worst case scenario. If you think it's dry and you spread your urea and then the dew comes in the morning, whoa, your losses can be 50, 40, 50% due to volatilization. So when to consider again when the potential for volatilization is high. Surface applied, prolonged, a lot of people, pardon me, they say use it for peace of mind. Well, even when I used to work for Coke, I would tell farmers, you got to decide whether you need it or not. If you don't need it, don't use it. Anyway, so when you look at the volatilization of urea, you can see urea reacts with water and hydrogen. Hydro, either it's Greek word, means water. So it's the hydrolysis, and it's mediated by urease. And when it's, you produce ammonium, as you can see, but at the same time, unfortunately, you have that carbonate that is being created. And what the carbonate does, it increases the pH around the urea molecule, or granule, pardon me. And if you look at, if your pH is less than 7.6, 7.7, you can see that what dominates in the soil solution is ammonium, but as the pH increases, you can see that ammonium dissipates and ammonia is being produced, and we all know ammonia is a gas. And there is an example there of a soil with a pH of 6.5, but in the vicinity of the urea granule, the pH has gone up to 9.6, and there are measurements showing that they can go as high as 10.2, 10.3. I've had those, measured before. And there's a lot of work in Montana State University actually showing all these increases. So the recommended practice to lower volatilization, you go back to the 1990, use urease inhibitor, slow release forms, you can see 1987, irrigation shortly after application that in Oregon, and the most common, though, that practice in Western Canada has been dip banding fertilizer. And dip banding is placing the fertilizer at least 2.5 inches, 2.5 to 3 inches deep. Here is a really amazing thing from Holcomb, from the Oregon State University. They broadcasted urea, and they applied, it was a dry soil, and they applied different amounts of irrigation. When they applied, as you can see, 1/2 inch of irrigation, their losses was anywhere between 50 and 75% of volatilization losses. However, when they apply 0.8 to 1 inch, 0.8 inch of of irrigation, the volatilization went down to pretty much nothing. I've had farmers that call me and I say, well, you know something, you're gonna broadcast urea. If your weather says you're gonna rain tomorrow or the next day, just wait and go apply before it rains. Then you don't have to worry about, So when it comes to dip banding, I had the distinct pleasure to work with the father of dip banding in Western Canada, John Parapia. Actually, I was hired by Westwood to succeed him. And what happened was in the 70s, anhydrous ammonia came into the prairies, and farmers were finding that they were getting a heck of a better yield with anhydrous than they were getting with urea, because they were broadcasting urea at that time. And John said, whoa, chikai, I think he said, wait a minute, let's put urea where we're putting anhydrous. And there we were. They got exactly the same yields. And that's how dip banding came into the picture. And John, had average rate, from a number of studies. Now, this is also the volatilization, some research that Cindy Grant and Ramona Moore did in Brandon. And you can see that when urea was broadcast, that the volatilization was very high, but when the urea was, even with the super U and amidas, the volatilization was very high. Unfortunately, I cannot. Oh, there. Up there. But when they banded the fertilizer, you can see how the volatilization was decreased. So, in conclusion, when it comes to volatilization, dip banding is the golden standard and remains the standard practice in Western Canada as far as minimizing volatilization losses. However, as the farm size increases, you band normally going at 4.5 to 5 miles per hour. You can broadcast going 15 miles, 12 to 15 miles per hour, and people want to go faster. And if you have 20,000 acres, if you leave 1,000, now that's a lot of money, So you've got to take into account, that. So recent results in Western Canada support the use of urease inhibitors to minimize the risk of nitrogen losses when dip banding placement is replaced by shallow banding or broadcasting. And if you were in some of the older MACs, I showed some of this data, but I'm not going to spend any time today. So are all volatilization stabilizers the same? Well, there is some really good work that was done south of the border. Dr. Jay Goose, and Dr. Franzen did a lot of work. And you can see in this graph, you have a number, you have, the bottom is urea treated with agrotane, and the top lines are all urea with a number of other products. And you can see the volatilization was much less with urea treated with agrotane than the other products, suggesting that that's probably the most efficient product. Also, there is that, Again, from another study that Dr. Goosen did published back in 2019. Again, you can see the control. Of course, the ammonia loss was next to nothing. And when urea was treated with Agrotane Ultra, is that black line. And then the rest of the products, you can see that they were all pretty much the same when it came to volatilization losses. So managing nitrogen loss for hard red spree wheat. This is also from down in North Dakota. You can see the losses. There is urea, the wheat grain, the yield. The red one is again Agrotane coated urea, and then that's urea alone plus ammonium sulfate and amidas, which is another product that with ammonium, it's urea with ammonium sulfate. Now the theory behind that is that, and actually if you go into the EPA, you'll find out that ammonium sulfate is registered as a volatilization inhibitor, but even Jay Goose, that did a publication, feels really bad about that, you know, because the idea behind that is that because ammonium sulfate drops the pH in the area where it's applied, it reduces the pH, and as a result, the volatilization is reduced as well. So here you can see that the maximum yield was Agrotane treated urea, and when it was, you know, as far as the fertilizer source is concerned, urea with ammonium sulfate statistically gave the same result, and then urea alone and amidas came afterwards. So now let's move into the nitrification inhibitors. And when it comes to the nitrification, the leaching and denitrification, the losses occur due to nitrate. Of course, and again, that is an enzyme-mediated reaction. The ammonium monoxygenate. And therefore, you know, when ammonium, you can see urea is converted to ammonium, ammonium is converted to nitrite and then nitrate. And if we have a means of reducing the action of the ammonium monoxygenate, we can reduce both leaching as well as denitrification. You never go zero, but you reduce them. Okay? So there is this is a really nice graph from the Soil Science Society of America journal showing how the organic matter, it's done in the lab, but it's a study that was done down in the US and shows how the release of nitrogen is from different soil organic matter contents. Now, they only are between 1% and 3%, and here you have soils with 6 and 7% more, you know. But you can see that the higher the organic matter, the higher the supply of nitrogen is going to be. And I would really like to see what is our soil organic matter now compared to a few years back. I tried to find some stats, but that's a different story. So anyway, denitrification and leaching of nitrogen when we apply urea or ammonium fertilizers like ammonium sulfate, the ammonium is converted to nitrite, and then the nitrite to nitrate, and through the action of enzyme, as I showed you. And the nitrification inhibitors, what they do, they reduce the enzyme's oxidation action, and as a result, they prolong the presence of ammonium in the soil. And we all know ammonium is a cation, it's absorbed onto the surface, onto the negative charges of clay as well as organic matter. So that's a good thing. Also, limiting nitrification of ammonium will also minimize the emissions due to nitrous oxide. And you have Mario here doing all kinds of work on nitrous oxide. So the nitrogen, this is a really interesting PhD thesis that was done at the University of Saskatchewan back in my days when I used to teach there. There was a grad student, Oleg, that did his PhD with my prof there that I did my PhD, Don Rennie. And what they did is they looked at the impact of fall applying nitrogen under zero till and conventional till at that time. As far as the availability of nitrogen in the following spring, and look what they found. They found out that up to 35% of the nitrogen that was applied in the fall was lost due to denitrification, due to the snow melt in the spring. Isn't that amazing? So it's a very important to keep in mind, because here, you know, like, look at the snow out there. You know, if you spread fertilizer this fall, well, you may have that. So anyway, so the potential of denitrifications was way higher under zero till than under conventional till, because it's a bit, the leaching there, or the movement is really reduced. And where there were crop residues, of course, you know, the yields were losses, and when the temperature also went above 5 degrees, the yields, the losses were not really affected. So dual inhibitors are those that have both nitrification and volatilization protection. The pros of the dual inhibitor is they have urease inhibitor, stop the volatilization, nitrification inhibitor, stop denitrification. That's the primary, you know, leaching. We have some leaching losses, but they're not as high as denitrification. And then integrated active ingredients, they're immediate or an extended nitrogen availability, and also they're safe to soil biology, the dual inhibitors. The cons is no time delay or controlled release mechanism, as polymer-coated urea would be doing. So are all the nitrification inhibitors the same? Well, the answer is the right source and the right rate. Again, good old Jay Goose did the research, and here we go. You can see that, you know, these are the residual ammonium, and you can see this is Super U, which is a dual inhibitor. It contains DCD and MBPT. I don't know if you were here 9 years ago when Dr. Fernandez was here from Minnesota, and he gave a presentation, as a matter of fact, on inhibitors. And when it comes to DCD, I don't know if you were here and you remember, he said, in order to get maximum protection from denitrification, the concentration of DCD has to be 1%. And the only product that gets near that is Super U, because it has 0.85%, or 8,500 parts per million. And by the way, there is no way you can coat urea with 85 parts per million of DCD. You're gonna create a soup. So what they do is they apply the DCD when urea is what they call the liqueur form. In other words, prior to, you know, making the urea granules, and they mix it and then they produce, you know. So there is no way you can apply 1% or 0.85 or percent or 0.5%, you know. The water is going to be too high. So that's really important. And then of course that's urea instinct. And then all the other ones, end zone, control, and so forth. You can see how it was, you know. And also here is some other, again, from, you know, showing the percent of nitrogen in the ammonium form after 4 weeks. So you can see that 71% in Super U was as ammonium, 56% of instinct as ammonium, and the rest of them were 10, 12, 15%. So always check the concentration of the active ingredient. And this is from a scientific presentation and paper that I wrote back, and I presented this data. I'm not quite sure whether I presented it here. I know I presented it at the Saskatchewan Soil Science Workshop. But anyway, used, you know, Super U that has the MBPT and the DCD, and then 85 parts per million, and then I used another product that has 17% MBPT and 25% DCD, and I treated urea with that, and here is the results. You can see that the maximum, and that's all the sites, and actually there were a couple of sites where the weather was quite dry and we didn't see any difference, but from a statistical point of view I have to put everything together. And you can see that the maximum yield was obtained with Super U, and that product really that had the lower DCD did not give any different results than urea. And again, what's the best practice? Deep banding, You're never gonna, so so when it comes then to the right place and right time, when to use nitrifications in Western Canada, when one will be exposed to losses from nitrate due to denitrification. Fall application or early spring applications, spring melt, as I showed you, the PhD thesis, irrigation or wet light soils, and finally, wet heavy texture soils or continually wet soils. And here is some results from the research I did, and actually there is an average of a few sites across 11 sites across Saskatchewan, and Kevin Barron is here someplace. I saw him before, and he was working at that time with Mario Tenuta. There are some sites from Manitoba included in here. You can see that it's not a 100% thing. Yeah, but on average there was a 13% increase in yield by fall broadcasting Super U versus urea. So, Also, we compare the benefit with fall broadcasting. It's a coin toss as far as those sites are concerned. Half of the sites were worse, the other half were better compared to banded urea. And depends very much on whether there was snow and moisture and things like that the following year. But how can you predict that? And again, I want to remind you what is the definition of an enhanced efficiency product. And I illustrate that with this graph. You can see that this is spring broadcast, shallow band, deep band, and of course deep band is fine, but look at this. This is spring broadcast. This is 100% urea, 70% of the recommended rate of urea treated with agrotane, 70% of nitrogen, the recommended rate is Super U. Same thing here. So the 70% in those all trials that I carried out in Western Canada for 3 years was the same as 100% urea. So that's enhanced efficiency products. If they're more efficient, if you're using the same rate for an enhanced efficiency product as urea, you're not gaining anything. Unless if the rate of urea you're using is not the right rate, and then you're going to get a yield increase. But if you're using the best management practices and you have the right rate of urea, if you're going to use an enhanced efficiency product, cut at least 20% back, Otherwise it makes no sense. So when it comes to nitrification inhibitors, you can see you have nitropyrin, DCD, DMPP, ammonium thiosulfate, and you can see the inhibition 82% by day 14, 53% by day 14, DMPP 4 weeks plus, ammonium thiosulfate a little bit, and you can see the nitrate reduction. It was measured for nitropyrin 60 to 93%, DCD 50 to 92, DMPP, and actually Philippe Azer has done quite a bit of work here with DMPP, 51%, there were no measurements with ammonium thiosulfate. And the ammonium reduction, just the yields summary, that's from Mario Tenuta. You can see how the side years and the reduction of nitrous oxide reduction, shallow banding actually and late fall application, things went up. So there was an increase. Whereas then a nitrous oxide reduction was great with polymer-coated urea, nitrification inhibitors, and split application, as well as nitrogen-fixing legumes. So, and the yield, you can see there was not very much difference, the percentage. It was not, you know, except for the organic production that he found a decrease of 32%. So this is all generated here in Manitoba. So the enhanced efficiency products now with physical coating, like polymer-coated urea or controlled release urea, that's different terminology that is being used. We know here the name is extra slow, no, ESN. Anyway, huh? Environmental safe nitrogen. I know, I'm calling extra slow nitrogen. And I was at a meeting at Agronomists in Calgary, and I told them, and they just couldn't. Anyway, well, you got to be, you know, if you use it in our environment, you got to be really careful when you use it. Anyway, understanding the nitrogen demand and nutrient application timing, the polymer-coated urea can improve plant uptake of the nutrient, reduce losses of the nutrient to the environment, and alter the time of nutrient availability to when actually the crops need it. And there are a lot of people now that are using blends of urea and ESN because they want to supply some of the nitrogen later on, you know, in the season. So the 4R, the right time. Time is very important for polymer-coated products. To be successful by using a polymer-coated product, you need to understand when the peak nitrogen demand is for your crop. And I have a publication for the nitrogen uptake, but I don't have the data here. 75% of the nitrogen for wheat, barley, you know, the cereal crop, is taken in the first 25% of the plant life. Corn is different because it has requirements at the beginning, but it has 2 more stages, 8, you know, and also later on where it needs nitrogen. So you have to supply some nitrogen later on, okay? But remember that. If the delayed release of fertilizer delays the nitrogen availability past the time when the crop needs it, you will suffer a yield loss. So when you need them, you know, can you use them? Broadcasting ESN without incorporating in Western Canada is not advisable. And the polymer coating, what happens is you need moisture. It has to hydrate and it has to release. And unless if you're going to have a lot of rain, snow, and so forth, then, you know. And this is for an example from back in my Westco days where we broadcasted and we went back to the spring, and look at that, it's still there, you know. So the right place would be seed placement is the best place. That's the absolutely best fit of polymer-coated urea or ESN in our environment. Seed place, you can add 3 to 4 times the safe rate by seed placing ESN. That's the best fit. Now in the Red River Valley, you can still, you know, but you go west, you know, and it's not the best. And I did many trials, so, you know. Anyway, so this is very quickly from Indian Hand, showing some of the results with ESN and Super U. They couldn't see very much difference when, you know, a side band. You know, you can see the difference they could see was with fall banding. You know, it was side banding is the green, no statistical difference. Fall broadcast, you could see the difference that Super U and urea was better than urea. And you can go to fall broadcast again, you can see ESN gave 54 bushels, but again, it was not statistically significant. And this is another, I'm gonna skip it because you know, I'm gonna show you 2 more slides because John says you're gonna slap me. Is that. And this is ESN on corn for a wet year and ESN, and then I'll show you ESN for a dry year. And you can see for the wet year with a nitrogen rate, you can see that the ESN gave the higher yield than urea at 100 pounds of nitrogen. Same thing with 150 pounds of nitrogen. However, on a dry year, it didn't make any difference. Okay, got the same yield. So, to conclude my presentation, know your fertilizer placement depth. If it's not deep enough, stabilize. Efficiency is about potential loss versus value of time. Understand how valuable time can be, since completing operations in a timely manner contribute to increased profitability, and that's for the large farms. The rate matters. Remember, again, what the definition is. And if you're going to use an enhanced efficiency product, you have to, you should drop the rate. Otherwise, you're going to be losing money left, right, and center. Find a balance between agronomics and economics. Highest possible yields does not usually mean the most profitable crop. Nitrogen management tools can help you determine what's maximum yield. Focus on the fundamentals of crop protection, nutrition first. Know when your crop needs nitrogen and apply it when the crop can use it. And finally, if the conditions do not warrant the use of inhibitors, don't use them. It just doesn't make any sense, okay? So with that, thank you very much for the opportunity to speak with you.